Good morning, good afternoon, and good evening, everyone. Thank you for joining today's webinar. Security Standards Are Evolving is your company. Create your own device security roadmap. This webinar is brought to you by NXP and Timesys Corporation. Our speaker today is Maciej Halish, Vice President of EMEA Business Development and Sales at Timesys. Before I hand the session over to Maciej, we'll cover a few housekeeping items. First, all attendees are muted. If you have questions during the presentation, please enter them in the question box in your GoToWebinar user interface. We will have a period of Q&A with our presenter at the end of the session. Second, you will find a copy of the slides for this presentation available for download in the handout section of the GoToWebinar user interface. Without further ado, I will hand the microphone over to Timesys.
Welcome to our webinar on security and standards and how those standards affect product design and development. My name is Maciej Halish, and I'm a presenter of today's webinar, which is brought to you by Timesys and NXP. Let's take a look at the agenda. First, we're going to restate the problem that we are going to discuss. So why do we care about security? We'll talk about security standards. I'll list a number of those different standards and how they get created. We'll then talk about how to comply with those standards, what companies are doing or should be doing in order to comply with these standards. We're going to discuss the plan for how to address the challenge of ever-growing numbers of regulations and standards, and how NXP and Timesys we can help in this process. Let's talk about security and restate the problem. Why do we care about security? Well, we care about security because we build embedded products. That's where we should start. And those embedded products, they are handling a number of different data, confidential, very often confidential data. A good example here is a medical device that handles patient information. That information is confidential. Or if we pay with a credit card, the credit card number, our information, expiration date, all that is confidential information. So we need to ensure that devices that handle this level of confidential information are protected from unauthorized access and use of the data. When talking about access, we need to realize that these devices nowadays, they are present all around us, regardless of market segment. I've mentioned medical, and that's the obvious one because nowadays technology in medical is on an exploding path. So we can buy many devices ourselves, but hospitals install great number of new technology devices in hospitals. So when we talk about this type of devices, of course, a patient has access to those devices, but others may also have access to those devices. Why? Because they are accessible. As opposed to, let's say, remote cameras, which may be mounted on some sort of poles and access to them may be somewhat limited. What is driving regulations? Well, we've heard a lot of stories, both in the news and reading on the internet about security breaches. I wanted to mention today two examples. First one is SolarWind attack. It's an attack that spread to company clients via a company's own update mechanism. In this scenario, end customers didn't have their own mechanisms for, well, identifying issues, identifying security breaches, and then they didn't have any ways of protecting confidential data. So once the malware was installed, it was used to steal that confidential data, and and customers didn't know that was happening. And that was the biggest issue. Um, when the cyber attack goes unnoticed, it can be very costly. That led, as a result, to an accelerated federal response. Um, the federal government issued a number of documents on cybersecurity. The second example I wanted to briefly mention is a very highly discussed and talked about hospital network attack, which was a type of attack that's referred to as a phishing attack. An employee opened a private email on a company's laptop while out of office. The email came from supposedly a customer, but it came with an attachment. The employee opened the attachment and then connected later on to through VPN to companies to hospitals network, and that provided an entry for malware to spread into a hospital network. It was a very massive spread and was a big headache for IT to basically identify all affected areas and subsystems in the hospital, caused problems such as computer glitches, network issues. When the hospital counted the losses, their estimate came at 50 million. And this is an example of a costly cybersecurity attack um, that did not affect human life. When we talk about vulnerabilities, when we talk about what and how affects embedded products, this is not news to anyone. The vulnerabilities have been there for a long time, and they've been known at certain numbers, which grew exponentially roughly 3, 4 years ago. Why? Because of the awareness. This awareness is great because customers now, knowing of potential issues, can demand manufacturers to implement a variety of security mechanisms that protect the downstream products so that end users don't have to worry about some of the common types of attacks or some of the common issues, security issues with products. So let's talk about regulations around security. I mentioned two different examples of cybersecurity attacks, and there was regulatory and legislative response as a result. Security has been recognized as a must have requirement when building new products. Government and non government regulatory bodies took action. Existing standards have been updated to take into account cybersecurity and security in general requirements. There's been also a very significant impact on the market. The awareness of vulnerabilities has driven the higher demand for security requirements in products, both at the device level, so to protect the different interfaces and functionality of a device, as well as long term awareness of potential vulnerabilities that may affect products. So, how the security is maintained over time for products. Before we go and discuss specific standards and regulations, I wanted to introduce what those terms mean. Starting with standards, they are established by organizations, standardization organizations, the most famous one being International Electrotechnical Commission. Those standards are designed for specific domain. It can be networking, communication, it can be processes for manufacturing, or standard requirements must be met by a product in order for a product to claim the compliance. Then we have regulations. Um, Regulations define rules to ensure a common baseline for products and services. They can be put in place by organizations, such as government and non government organizations. And of course, products work to be compliant with them. So, what is compliance? It's simply adherence to specific standards or regulations. Compliance may be different for different companies or products, depending on, let's say, operating environment, where the device product is placed. Product A is if it's connected to internet, it has different types of, let's say, requirements and regulations that apply compared to product that is not connected to a network. Next, let's talk about examples of various legislation and efforts by various organizations. There are a lot of legislative work done, which is regional. Starting with Americas, we have the IoT Cybersecurity Improvement Act of 2019, driven by NIST Laboratory. There are also different regional bills that take into account um, security requirements. In Europe, there is the European Cybersecurity Act, um, the EN 303645, which I'm going to talk a little bit more about today, provides the consumer IoT baseline regulation or standard. And then we have in um, Asia Pacific various regional organizations in Singapore, China, Australia that also create different um, legislation that drives the improved security for products. On top of that, we have those different organizations that drive um, security regulations and standards um, across all the continents. And we have here the IEC 62443, which helps with industrial IoT. We have the PCI PTS standards regulations for payment terminals, similar regulations for automotive, for products that are consumed worldwide. When talking about regulations, let's start with the US. The primary organization that provides regulations is Congress, um, where the acting unit is the Department of Commerce, under um, which we have different organizations, including the National Telecommunications and Information Administration, and the second one is the National Institutes of Standard and Technology. The latter one is the um, laboratory and non-regulatory agency of the Department of Commerce. We also have local governments or state level governments that uh, also put different bills and regulations in place that nowadays take into consideration security, cybersecurity. In collaboration with U.S. government, has created the NIST IR 8259, um, which is the foundational cybersecurity activities for IoT device manufacturers. So Internet of Things devices often don't provide device cybersecurity capabilities that would allow end customers to help mitigate their cybersecurity risks. Um, and with those regulations, manufacturers can now help their customers by providing necessary cybersecurity security functionality to improve the level of security of uh, products. This particular publication describes recommended activities that relate to cybersecurity that manufacturers should consider um, when um, when building IoT products and releasing them to customers. Um, on the local side, we have for example, the Senate Bill number 327 in California, um, which I believe was put in place in January of 2020, um, and it requires a manufacturer of connected devices to equip those devices with reasonable security features or features that are appropriate to the nature and function of the device to handle in a secure and confidential way information that that passes through it, and to ensure confidentiality, prevent unauthorized access, modification, or disclosure of information. Similar bills are passed in other states. Maryland, for example, has the House Bill 888. So in Europe, we have, for example, in UK, we have the Department of for Digital Culture, Media, and Sport, as well as the National Cybersecurity Center, which assist with those different regulations. We also have the European Union Agency for Cybersecurity, the ENISA, which is tasked with assisting European Commission and member states um, to meet the requirements of network and information security. We have the standardization body, the European Standards Organization, ETSI, which is a recognized standards body dealing with telecommunication, broadcasting, and other electronic communication networks. Um, they have put in place um, jointly a variety of different regulations, such as IoT Code of Practice, baseline security recommendation, good security practices, as you can see here. And Etsy also created this EN 303645 standard, which was released in April of 2020, which provides the baseline requirements for cybersecurity for consumer Internet of Things devices. That regulation has been then leveraged by other governments in other parts of the world, including Australia and Singapore. When discussing product design, we need to take into account the security needs. On the right-hand side in this slide, you can see that security requirements is something that should be considered way ahead of design and implementation of the product. The requirements should take into account and protect against various attack vectors, whether it's physical, network, um, local. It should take into account also the environment in which the devices operate. Um, the requirements need to guarantee confidentiality, device availability, and integrity. Um, and when planning to implement different security features, you need to also plan to develop tests that verify the use cases that are desired, but also use cases that um, are not planned for but are possible. Um, and in case of a security breach, you need to plan a course of action. So what do? Well, you disclose the information. How do you disclose it? Um, do you need to do a software update? Do you need to implement security fix? What do you needs to happen? Um, and also, you need to take into account how security will affect device manufacturing and servicing, and how to recognize when new vulnerabilities are reported and how they affect the product. Last, not least, you need to also take into account the security of software supply chain. When you get software from someone, is that software somewhat secure? What level of vulnerability information can you get for that software? So talking about security requirements, we need to realize that there's a lot of commonality amongst security requirements for products, whether you are building a product for a medical device or an IoT device, automation device, automotive device, requirements, security requirements are quite common. The mechanisms, the specific mechanisms that get implemented depend perhaps on the market, but when requirements are drawn, um, there's a lot of commonality. And the same commonality you can see while reading through different standards and regulations. I wanted to draw this parallel here because when we are bombarded nowadays with the standards, regulations, well, we are building products for different market segments. So we need to be aware of regulation in US and a regulation in Europe. So thinking of that and thinking about the commonality, um, we can relax a little bit because all these standards and regulations are trying to address similar issues, similar challenges. So when we solve the challenges for one standard, very likely we are already going to have a 90% solution for other regulations and standards. So, discussing product security, we need to make a statement that security is not a solution. Security is a process, or as a matter of fact, it's multiple processes. And when we talk about processes, we can see that compliance likes the process because when you describe how you're going to protect certain things, um, that's what compliance, that's what standards and regulations are calling for. Tell us how are you going to ensure confidentiality of process data, for example. So process, there's multiple processes. The first one is the process of designing security features into the product, which take into account um, certain must-have security requirements, such as secure boot for software authentication, um, can take into account secure key storage, which is uh, which is provided by NXP's hub, and encryption is aided by CAM module. Um, we have a process of monitoring software used in our products for security vulnerabilities. We have another process that um, we need to put in place to address discovered vulnerabilities. Um, and once we address the vulnerabilities, there's another process of deploying the firmware updates. So each product which takes security into account, and we talked about the fact that it's a must-have requirement. So um, I guess we are talking about 90 plus percent of products right now built in different market segments. Um, each of these secure products needs a security lifecycle, and that security lifecycle must be supported by multiple different processes. Okay, so let's take a closer look at one of the standards, the IEC 62443, um, from a perspective of a process or processes. So 62443 is a series of standards developed by the committee and adopted by the International Electrotechnical Commission, which provides a flexible framework to address and to mitigate current and future security vulnerabilities in industrial automation and control systems. Looking at this picture, you can see that 62443 takes into account different information. There is a general information, there is policies and procedures, system information, and component level information. Um, so there we talked about processes and the component level. You can see part one talking about secure product development lifecycle requirements, and there is also technical security requirements. Um, that's at the level of automation device supplier product development. We have under policies and procedures asset owner um, requirements for security protection, um, patch management. Continuing on the 62443, you can see that it has regulations, it has the information that affects the development process and then product certifications. Um, when discussing the product compliance, product certification, there is the common criteria for product certification. So when doing um, product certifications, we take requirements for common criteria for market-specific standards, and that translates into processes, which then translate into certifications. Who deals with security requirements? Let's take a look at various members of our teams that are exposed to security. If we have security officer or security team, they are probably the key personnel on our team that are in charge of everything security, responsible for designing, requirements definition, compliance with rules and regulations. They are establishing the security policies in support of business goals. They are also the ones that are um, putting in place processes for monitoring cybersecurity, um, um, monitoring devices for breaches, and design what's going to happen when a breach occurs. The next team is our development team. Why? Because they are responsible for implementation of security requirements and implementation of fixes for vulnerabilities, perhaps. In many organizations that we work with, development team um, plays a role of the security team for the company. But they can be, of course, two different teams. We then have a test team that's in charge of validation, historically functionality validation of a product. But nowadays, they are also responsible for verification of security requirements and verification of security levels and compliance to standards and regulations. We also have manufacturing team, which is responsible for ensuring that specific security mechanisms as implemented by the development team are engaged before the product gets released. And we have finally a maintenance team, which is responsible for new security vulnerabilities, responsible for um, firmware updates, rollout to field, and they also need to make sure that it's all done in a secure way. When talking about security and those teams, some of the challenges that teams or companies, organizations face are the fact that they lack in-house expertise around security, good understanding of um, security mechanisms that are available, how to design or implement security requirements, or what security requirements are um, needed in the first place. We have also companies that don't have prior experience with embedded Linux, therefore it's difficult for them to identify how to meet security requirements. Um, we've worked with companies that are treating security at a lower priority compared with functional requirements, which is a challenge. Um, and in many cases, there is no prior experience with meeting regulatory requirements, with working on compliance for a product device that is to be released. So that's, I would say, one of the bigger challenges that we see our customers face. Let's talk about industry-specific regulation for security, and I've chosen a medical market as an example here. So 62304 is the standard that provides the framework um, or that defines the framework of lifecycle processes with activities and tasks that are necessary for the safe design and maintenance of medical device software. The standard puts the requirement on a company to create a development plan with very well established quality, safety, and risk management systems. There should be also a clear plan to um, maintain the product for security long term. This particular standard is used by FDA in the US to regulate the, the acceptance of devices in medical field in US, and similar regulation is issued in Europe. It's called medical device regulation that European manufacturers have to adhere to. The standard itself um, helps define a checklist for compliance for these medical devices. The basic dilemma is how to treat integrated software that was not developed by certified manufacturers. We, in medical markets, typically deal with third-party software that oftentimes is developed according to required medical standards, 62304, 13485, or some other FDA regulation, for which technical documentation exists and is available to the manufacturer. The other option, especially when we work with open source software such as Linux, is to use a software of unknown provenance. It's also referred to as off-the-shelf software. In this case, the onus is on the manufacturer of the device to document the software that's being used in the product. In case of Linux, we are dealing with software that's developed by an unknown developer that's widely available, it's free. There's existing documentation, but it's not adequate to, let's say, the documentation that's produced for certified software. So it's a responsibility of the manufacturer to create software requirements, define software architecture, do a risk analysis, plan for software maintenance, and how they are going to address the cybersecurity. So when working with open source, in case of medical market, the device manufacturer needs to create this soup document that captures a lot of that information, um, and it helps track also the software that's being used in products. And that concept is quite actual right now because in US there are new regulations that are being drawn for SBOM. So this is software bill of material security, secure software bill of material that helps companies track what software is being used in products, and then once you know what software is used, you can track adequately the cybersecurity information vulnerabilities that affect that software. FDA has created a pre-market guidance addressing those concerns, or forcing the companies to address these concerns. Cybersecurity is one of those areas that FDA now mandates that is being taken care of during the design and development of a medical device. It establishes design inputs for device related to cybersecurity, has requirements for the process to manage the vulnerabilities long term. In the next slide, you can see an excerpt from this pre-market submission guidance document. And this one is about designing a trustworthy device. You can see here different requirements and how those requirements translate into tasks that engineering team typically need to implement. Prevent unauthorized use translates into access controls, OS hardening, firewall, secure boot, chain of trust, ensure trusted content by maintaining code, data, and execution integrity. So again, secure boot, chain of trust, and so on. So you can see that the document outlines requirements, which can be then fairly straightforward translated into processes and tasks for engineering teams. How NXP and Timesys help with security compliance. So let's talk about that. So we have an IMX8 device product in this case, and we have certain standards and regulations that are market specific. There are functional requirements for a product. So starting with that, and then we have use cases of how the product is going to be used. Use cases describe functionality, but also provide background information on potential attack vectors. So that also has an impact on security requirements. So we have functional requirements, security requirements, which we can do then the mapping against standards and regulations. Mapping translates into a checklist, an Excel spreadsheet, or some other list that you can maintain for the product, where you can add descriptions and mark which of the rows are met, or which requirements met. So the mapping can be leveraged to create a test plan for also certification. And that test plan includes security testing, penetration testing, to verify that, in this case, security requirements are met. To meet the different regulations, guidance, there needs to be a customer proof that translates into test reports, security reports, and then the checklist that that we are talking about here, checklist stemming from the mapping, which, when completed, helps the product meet the compliance and achieve the certification. Using the one of the standards that we've discussed earlier, the 303645, that provides the baseline for IoT devices. An excerpt from that document here shows you a set of requirements, right? So the mapping can be done based on item number, how you're meeting the specific feature. So no universal default password. Secure by Design, which is a service offered by Timesys, can assist with implementation of a variety of those security mechanisms. We typically assist with, well, the whole gamut of functionality that, or secure functionality that can be leveraged in compliance. So here we have OS hardening, we have um, secure over-the-air update with Linux OS maintenance. We have secure key storage, secure protocols and ciphers. For secure key storage, we can leverage also NXP's secure elements. So there's hardware-assisted solution there. There's a secure boot and chain of trust for and to ensure software integrity, um, to ensure the um, confidentiality of data that's being used. We assist by implementing encryption and authenticated storage. So there's quite a few of features or solutions that we can help implement to meet um, security requirements that are captured in your mapping spreadsheet. On top of that, Timesys offers the Vigilus solution, which was discussed earlier in one of our earlier webinars. That is a solution, a product that assists with monitoring of vulnerabilities long term throughout the product lifetime. Vigilus also provides security if you don't how to fix vulnerabilities in time. So very valuable tool to have in your toolbox. When discussing the security lifecycle, I'm going to use um, that picture that I showed you in one of my earlier slides where security requirements are on top. So when discussing um, meeting the compliance, on top, we have the industry security standards and this custom checklist that's created as a mapping between the requirements and the security standards. Um, and now we can go down here um, through the security lifecycle to see uh, what are the different processes and things that we need to do to ensure the proper security lifecycle. So we start with security requirements. If we don't know what security requirements, we should consider there are trainings. There is, of course, threat modeling. There is risk assessment that you can do for security requirements. Then you move to a design and implementation phase where you build your OS, the baseline Linux OS, the application. You design your hardware. Maybe you start with hardware, right? And then you move to testing, where you verify the um, functionality of the product, but also you do testing of security of the device. So you run the tests that verify implemented security features, but you also do the test penetration testing. Um, you and then you go into manufacturing process where you need some tooling support to properly engage security features. And then once the device is in the field, you need to have you need to have a device management system in place, a way to update software that's executing on devices in the field, and then manage perhaps applications in the cloud in a secure way. When a device is in the field, you also have responsibility to implement a disclosure program to um, inform downstream customers about new vulnerabilities that are reported that may affect the security of a product, may jeopardize the information that the devices is processing. How do we assist with this security lifecycle process, you may ask? Well, here's a bit of color coding to this lifecycle process. We at times can assist by providing a security questionnaire. So if you're new to security in embedded Linux and you need to meet certain compliance, and you need to implement certain standards. This security questionnaire can be a baseline for your custom mapping, custom checklist. We do assist with custom checklists. If you have your own custom checklist, we can work with you to fill in appropriate information on how specific items on your list can be met with available security solutions. We assist by providing trainings. Our security experts help with threat modeling. Um, we do assist with implementation of OS, baseline OS, so with all the security features that you may require. So secure by design services are coming here. We do help with development of tests, so how to verify that the specific security feature is engaged and it's working as expected kind of testing. We help with documentation and manufacturing tools. We do have documentation available for various processes that our solutions support. So Vigilus, as I mentioned, is a tool that assists with monitoring of vulnerabilities that apply to your product, and there's an entire process that you can implement around that tool. We do have documentation and can help you set it up. We also do BSP lifecycle maintenance for you if you would like to go that route, um, leveraging also Vigilus tools. So um, that and in addition to that, we offer documentation on engineering development process if we are engaged to implement secure by design features for you, documentation for maintenance and vigilance, as I mentioned earlier. Main areas where we assist hardware selection. This is something that both NXP and Timesys can assist with. If you have specific security requirements, we can provide advice as to which security features of the hardware itself, the processor, can be leveraged in your product. Secure by design services that we offer, they span through many different areas. I'm not going to go over all of these areas in a slide here, but you can see from secure OTA hardening, OpDE, to some of a runtime protection. And as I mentioned, Vigilance and BSP maintenance are solutions where we can help you with long-term security of your product, and that long-term security of a product is one of the key requirements in standards and regulations um, that are published or are going to be published in the near future. So a few more words on Vigilance and BSP maintenance. Again, those two topics have been covered extensively via dedicated webinars before. So I'll provide at the end of this presentation links to those recordings. But briefly, Vigilance is a tool for monitoring vulnerabilities, triaging, reporting, tracking fixes. It's designed for your engineering team, security team. It has integration into continuous integration, so it plugs into Yocto, build root, and helps monitor your products long term for security. It's very easy to integrate, roughly 10 minutes of your engineering time. Very easy to use and provides very highly accurate security reports. You can learn more by visiting our website. I'll provide the link here below. And next, I wanted to do the same for BSP maintenance to introduce a bit more. So it's a service offered by Timesys where we maintain security of your BSP and product long term. In this solution, we use Vigilus. We do monitor, triage, patch, build, test your products, provide reports. So you get updated sources, binaries, reports, many of the checklist items for compliance. You can learn more about how we do BSP maintenance by following this link here. So what are the takeaways from today's presentation? Security is a must-have requirement, and that's something we've established. Um, and security is nowadays integrated into specific market-specific standards, regulations. It cannot be deferred. You can't postpone implementing security if you're building devices that need to have certain compliance. Um, if you add security at the end, rest assured that that will greatly affect your schedules and the overall cost of the project. So using ready-made solutions such as Vigilus BSP maintenance, secure by design services um, provide you with an easy way to fill in those check boxes on the compliance documents, on the compliance checklists. Um, we have ready-made solutions, um, processes that you can leverage. We have documentation that you can leverage. Um, and regarding NXP security features, there is a lot of information available on NXP's website. I'm going to provide here a link to some of the documents I think are interesting for you to read. So, what is the call to action from today? Well, the call to action is really just one: talk to us. We are security experts. We've helped numerous projects and companies with implementation of security features. We are working with products that are filing for compliance. We do understand um, many of the market specific dealings or things that you have to do. So even if it's just you know sipping coffee and talking to us about compliance, please do. We do have an ebook that's coming out right around right now that a colleague of mine has put together, which is Guide to IoT Security. I'll share the link to this document when it's available, when it's ready. And I've mentioned previous webinars. I'm not going to go through this, but you have access to slide decks, so you can access this information yourself. Um, and with that, I wanted to thank you all for joining me today. And let's switch to questions.
All right, thank you so much, Mache. Um, before we before we launch into the Q&A session, we do have a quick poll for the attendees. And our first poll question is actually whether or not you would like to receive the ebook that Mache mentioned. So just a second, I'm going to switch over so I can share my screen and then launch the poll. And it's the cybersecurity primer for IoT and embedded devices. So just let us know if you're interested in receiving that, and we'll send it out in the next business day or two. I'll give you just another moment to finish that poll. Okay, I'm closing that one out. And our next poll question, do you currently have a project in development or are you planning a project where security is a key requirement? Just one more moment there. The votes are coming in. Okay, next poll question. What is the driving factor for your product security requirements? And I'll read the answers here. Our customers are scanning and reporting problems. We need to meet industry compliance requirements. My company has internal cybersecurity guidelines, or we are interested in developing internal cybersecurity guidelines. I had to abbreviate some of these answers, so I'll go ahead and read the rest of them to you. We have 2 more questions after this. All right, I'm closing that one out. And the next question, how would you describe your current security process? Pick all that apply. Number 1, we don't have a product security process currently. Number 2, we currently have a process for implementing device security during development. Number 3, we currently have a process for monitoring vulnerabilities in the third-party software used in our product. Number 4, we currently have a process for keeping our software up to date with security fixes. Okay, last poll question coming up. The question is, what security challenges are you currently faced with? Option 1, lack, and you can pick as many as you want. Option 1, lack of in-house expertise in security on embedded Linux. Option 2, lack of resources to integrate security requirements. Option 3, treating security at a lower priority compared to functional requirements. Option 4, no prior experience in meeting compliance security requirements. And option 5, lack of tools or ready-made solutions. All right, I will go ahead. Well, I still have votes coming in. I'm going to wait one moment. Okay, I'm going to close that poll out as well. And now we can move into the Q&A. The first question is about licensing, and the question is, can the tool be used without a license?
So I assume that we are talking about the Vigilus Prime tool that can be used for monitoring of vulnerabilities. And the answer is you can register for a 30-day free access to give a tool a try to see how what type of information reports and how you could leverage that to in meeting your compliance. But to use the tool long term, there is a license required.
Okay, great. Next question, can you do our device certification for us?
Yeah, that's a good question. So we get it a lot, and the answer to that question is that, well, not really, because what gets certified is your product. There is probably a lot more questions about product and industry-specific things, which we may not be aware of. Therefore, we typically don't certify products for our customers, but we assist in that certification process by helping implement the different processes I talked about today, by providing documentation, by using the tools that we offer.
Okay, next question. What information do I put in SOUP?
Right. So well, there's actually, that depends to a degree. You typically have to document everything about the software that you're using, software that comes from well, software of unknown provenance. So you specify package name, origin of the package, who created the package, how it's maintained, the version of it, the licensing of it. So there is multiple columns in a spreadsheet for SOUP that you have to consider. If you Google SOUP templates spreadsheets. There's several of them, I think, floating around on the internet.
Okay, great. We're right at the end of our time, but I only have one more question, so I'm going to squeeze it in. Um, the question is, we need to claim compliance with new regulations that require us to prove we have a long-term security maintenance process. Where do we start?
So in this case, well, everything starts with policies and internal policies for security. Either a security team, chief security officer, or somebody in an organization that's responsible for security needs to create a set of internal guidelines and regulations on how the company is going to handle um, security information. When it comes to vulnerabilities, for example, companies typically specify in their internal policies that they need to resolve high and critical vulnerability issues within a specific period of time, 30 days, 60 days, for example. And we're talking about being able to address the issue when the solution is available. The policy also takes into account the response to downstream customers, to people who operate the devices, right? So, in an event there is a critical issue that can really affect confidential information, the disclosure policy needs to be very clear, so that well, people stay informed, even if the fix is not in place. So that's where I think I would start. And then from that, as you look through different standards, regulations, there will be additional information coming out of this, and you turn that into um, checklists, and of course they can help with further definition of internal policies for security.
Okay, thank you for that answer. Thank you for all the information that you've shared today, Mache. And thank you to everyone who's joined the webinar. We'll go ahead and close it out now, and we look forward to talking to you again soon.